Hey, boys and girls, we are live. I'm a little messed up tonight. I'm hoping my co-host here is not. For some reason, I can only see out of one eye, but both of them are open, which is kind of disturbing. I don't know why, but
free sides.
Yeah.
So
for some reason, the left side of the world
we're going to be evening ranting, yo.
Yeah.
All you Joe Cool kids out there.
About standing for truth.
Hey, Mark.
You and Marshall.
You
and Marshall were on a stream last night with him, or chatting, basically, in the chat. Was that it?
Yeah, we were both in the YouTube chat, right?
Yeah.
That was bad.
I am about to do a transcript.
The SFT actually even put a couple of my chats up on screen and pretended to address them, but...
Okay, let me take a look at this. I have a transcript. You guys go ahead and figure out what you want to talk about, because I don't know what the hell I'm doing right now.
Also, Atheist Junior from the chat said he did his interview.
He did what?
With, I think, Kent Hovind's ex-wife.
Oh, when was that? Did I miss it?
He just said that right now in the chat.
We have to, I'm going to have to watch that tonight. Oh, he did it, but has he posted it?
No.
Okay. That's kind of what I thought.
So Marshall, what do you think about SFT stream in general yesterday?
Oh man, it was a let me think how to put this. Well, it essentially it was SFT and Rawmat pulling bullshit out of their out of each other's asses and spreading it over what Dan was saying and pretending that they were debunking Dan.
Yeah, it was so frustrating, honestly. It wanted to make me bash my head against the wall, to be honest.
Yeah. Oh, that's what that phone message was last night about you bashing your head against the wall.
Yeah.
You didn't give me any context. It was just.
Call me.
I actually didn't even.
Hey, Emo.
I didn't stay for the whole thing because there were other streams starting that I wanted to watch, and I realized it was just a waste of time.
Yeah.
Yeah, I mean, just what like I don't understand the paper they're talking about in general, but like I know when they get stuff wrong about phylogenetics because this is my topic, man, and I'm by no means an expert in it. But I think I know a heck of a lot more about phylogenetics than the brain trust in the gang. I mean, like, if that's anything to go off of. But, like, I guess where to start? I mean, like, didn't they say something about how, trying to remember, but, like, they mentioned Carlos Linnaeus and how he was using this classification system and how it was based on morphology, which is correct. But I find it funny how they always bring up Linnaeus and never go over the fact that we don't use his classification system anymore. at least not in the technical sense. You know what I mean?
Yeah, it's the problem is like they don't understand the difference between science and religion. Like, you know, if their holy prophet says something, well, they still have to stick with it. But science isn't like that. Just because Linnaeus got a few things wrong doesn't mean that the entire idea of phylogenetic taxonomy doesn't work.
Right. I mean, like he was the first. Well, probably not the first, but he was one of the first people to find these nested hierarchies, right? And like he couldn't explain them with a fixed species model with no evolution whatsoever. It was only when Darwin came along and then said, "Hey, what if we explain this with this? This being common ancestry." And that's where the idea started to be tested. And so the nested hierarchy, so we already knew common ancestry was pretty much an observable fact because of these nested hierarchies and the fact that they fit so well with the fossil record and morphology. And then in the 1950s and 1960s, we started getting right into how these phylogenetic methods can be developed overall with Willy Hennig, German entomologist. And since then, we found genetic methods, for instance, like maximum likelihood and algorithms based on that. And but of course, none of these creationists understand that. They don't go through the history of phylogenetics because, well, for one thing, they think it assumes evolution to prove evolution. In fact, they actually said that.
Yeah.
Okay,
Well,
so this
the
butter. Go ahead. No,
Well,
you
I
go
was
ahead, Mark.
going to point out that they also seem to be confusing, you know, the last common ancestor of a species with the origin of the species. You know, they don't understand that there wasn't a point when there was one of each of those butterflies, and that we're finding that they don't understand how speciation even works.
Right, and they also seem to be conflating gene trees with species trees, right?
Yeah.
Like I mean, like it. I think wasn't this particular study they're going over, like it was about a gene tree, not a species tree. It was looking at one or at least a couple of genes, I think, like specific regions of a single gene, and like maybe time will tell, and more genes will be discovered in the mitochondrial genome that can verify these patterns, but that's not a guarantee.
Yeah, I need to look at they did link the study they were talking about, but I hadn't had a chance to really look at it.
They linked it where in chat?
Yeah.
Okay. Yeah, they I just watched the first part of it, and I hadn't watched the second part of it. But this part about butterflies, where he came up with this picture comes up anytime you search for butterflies and barcoding, or if you search for owls and barcoding. But anyway, he shows this, and so Ramat the fruit bat, when he starts talking, if you really listen to, or try to listen to the sentences that he's putting together, he puts his foot in his mouth over and over and over again. And he's like, I don't know what the hell. So he's saying we have the mitochondria, and then we have the CO1 fragment right here, and then the chimpanzee. So that's what they're looking at. And then they did it with all the different animals. They went around, they said, wow, look at this. We have mutation rate that's really quick in this region, and we can differentiate between all these different things. Now, in the paper, they claim that Steckler and Thaler were saying they were shocked, and oh my God, they didn't understand why it was turning out this way. None of that is in the paper. Right. They don't express any shock. They have some ideas and some cautions for neutral theory and evolution that they talk about in the middle of the paper. And then at the end, they mention that it looks like for a lot of animals, a lot of extant species, that there were bottlenecks and that they came from bottlenecks. Okay. And right. then he says, without even knowing that they can literally just look at this fragment and say, oh, that belongs to the animal, this creature, and then they line it up with the other ones. For example, when you look at the butterflies, you see the butterfly is very similar to another butterfly, totally different species, but yet the mutation rate being fast, the speciated into this one, and yet there's enough mutations to tell even over a short period of time that one, they're still related, they're very related, and over a deep time, they would not be so related because the mutation rate's too quick, and they would look, it probably would look something like the owl would be, but we can tell the owl is completely different. Okay, so he's claiming that if deep time were true, that these two butterflies, which are slightly different, they're actually the same species, but apparently two different versions or something, or subspecies. He's claiming that they would look like the owl if deep time were true. So he's not making any sense at all. And this is supposedly he sits back like, oh yeah, just let me refute Dr. Dan. And then he spouts this kind of garbage all over it. And I was like, I was kind of pulling my hair out, what's left of it.
Yeah.
It was just like, what are you talking about?
Before I comment on that, do you happen to have John Peterson is here? Do you have his email?
Yes, I do.
Yeah, I don't know where Marshall went. Did you want to send John an email?
Marshall will come back. I want to keep the room light. Okay. Oh, Marshall is back. I've had him in the backstage for probably for an hour.
Sorry, I'm on my phone and I tried to look for that thing, but I can't open a new tab apparently and keep the stream open.
Oh.
Okay.
But yeah, when he got to that point, I think I just was like, he's not even wrong at this point. So
I mean, he wasn't making any sense at all.
Yeah, exactly. It's not even wrong.
Right.
Where do you begin correcting that?
I mean, there is a certain phenomena in the literature, and it is a hurdle to overcome phylogenetically. Is often called saturation, where so many mutations occur that eventually the signal, the phylogenetic signal, is kind of randomized, and it becomes more and more difficult to tell which species is related to, or which taxa is related to which taxa. And that's a general rule going back farther and farther along the tree in terms of the branch points. But I mean,
Right.
I think one that it seems to me like that would depend more on substitution rates than mutation rates, right?
Yeah.
I might be getting something wrong there, but it also seems like, okay, so he was claiming that the butterflies would be saturated over evolutionary time. Okay, can you restate his claim, because that doesn't make sense.
So we have two butterflies here, right, that are the same species, and he's claiming they were different species, and they're not. Okay, the same species, two different subspecies, and we can tell the difference with barcoding between those two butterflies, and that's why they like barcoding, because it gets these fine differences, right?
Right.
And he was claiming that if deep time were true, in other words, he thinks these two species of butterflies must have speciated millions and tens and hundreds of millions of years ago, right? So they would be as different as the owl if that were true. And yeah, they would be, but they would also look very different, because if they had split off 10 million years ago, they wouldn't be the same color. They wouldn't be the same species. So, I mean, this thing, who knows when this
now wait a
split
minute.
off.
So sometimes you do have speciation events where the two different species look morphologically very similar, but it's not until we start looking at the genetics that we realize, wait a minute, these are two different species, like tuataras.
And if you, but that's exactly the opposite of what he was saying. Okay,
Right.
These two barcodes are very, very similar, and he's claiming that they should be, because of deep time, they should be very different. Well, it shows he's talking out of his ass, because these two things obviously split very recently, right? Not in deep time, probably in the last 50,000, 10,000 years even. These two subspecies split. So he's claiming that, they should look as different as the owl. But then none of that makes sense, because then we wouldn't be able to use this. I mean, okay, so they use barcodes to figure out a particular species, but they can also see from the barcodes, they can see phylogenetic relationships, obviously. I mean, if you look at the owl and the difference from the butterflies, they're obviously very different. So, I mean, I don't know what he starts talking and he doesn't make any sense. And they run for a whole hour and a half doing this shit. And then they claim they've refuted something. It just,
I'm pretty sure mutation saturation only really kicks into gear when you get to the major animal phyla. So, like, the differences between, say, two species of owls, or two families of butterflies or whatnot, I don't think those differences are going to be as diluted as he thinks. I mean, like, even today, we can tell that owls are chordates, and that they form their own little group with echinoderms within deuterostomes, and we can tell that, and that butterflies make up they form part of the protostomes, specifically arthropods, and we can tell that going back even that far. So I don't quite get his point.
Yeah, it doesn't get until you get back where you're trying to figure out, like, where eukaryotes are placed.
Yes.
Between archaea and
because then you also get into, like, horizontal gene transfer,
right?
And hybridization and things like that.
Yeah.
Now, what we're looking at here is synonymous substitutions, right, across that CO1 gene or COI gene.
Right.
What is the name of that gene? It's something oxidation. And anyway, what we're looking at here is a very rapid mutation, right, in the synonymous substitutions. So it doesn't make any difference. It makes no difference in the phenotype. And they make a big case of that in the paper, that these substitutions are not going to make a difference in the phenotype. The thing is either going to work or it isn't, because it's very much involved in metabolism, right? So if this thing mutates that rapidly with these synonymous changes, then after 200,000 years or 1 million years, we may well end up with back mutations. And it isn't surprising that I don't know where they got the 200,000 years from. Yeah. But it looks like there was sort of a bottleneck 200,000 years ago in most extant living species, right?
Yeah,
but that's not surprising.
I need to look more into that, because apparently what I think happened was, like, they were actually just reading the introduction and reading the part where in the paper where they were setting up an alternate explanation to put forth their explanation. So I don't think that's why I need to look at the paper, because I get the feeling that they're quote mining there.
Yeah, I'm pretty sure that they just read either the creationist literature on it or the popular articles on it or something like that.
Yeah. Oh, let's see. I got the paper up here. Where is it? Okay, it's right there.
I'm also pretty sure that while Ramat was talking about this, he kind of pretty much demonstrated the basic phylogenetic methodology, which is basically one of these things is not like the other, and putting them into exclusive relationships. for the most part, that's kind of the basic foundation of phylogenetics. So, I don't know, I found that funny.
Right.
So here we have the beginning. Most barcode cluster reflects synonymous substitutions. The answer depends on whether variants are phenotypically neutral. During a population expansion that began approximately 100,000 years ago, talking about humans. Okay, they're talking about humans here. So we have to keep that in mind. And, we had a bottleneck out of Africa about 100,000 years ago. None of that's surprising. Standing for Truth again stated that we created the bottleneck idea because of the DNA information, and no, that's not what happened. The bottleneck out of Africa was something we've talked about, I think, since about 1920. The bottleneck idea was created because we know that's what happened, that we did come out of Africa. There had to be a bottleneck. There simply had to be. I mean, it was a result of migration.
Did anyone else think that Raw Matt's explanation for why there's more genetic diversity in Africa, did anybody else think that sounded a little bit racist?
God. Oh, yes, exactly. That's Jensen's
really
idea.
Oh, yeah. I didn't hear that part. What did he say?
Oh, because they start mating at 15. And and he made that case for something else too. Where did he? And I think pretty much there was. You could make that same claim about Europe, right?
Yeah.
I don't know where. That is Jensen's idea, and it's trashy racist.
Well, it also ignores that all non-sub-Saharan Africa genomes are a subset of a genome found in sub-Saharan Africa.
Yeah,
that wouldn't explain it at all.
Yeah, they're trying to explain the rapid mutation rates, and they've come up with a number of things like recombination hotspots. Apparently, there are more in Africa, but that still doesn't get you to a higher genetic diversity that we find in Africa. And Jensen keeps saying that we have to test the African tribes. We have, and they are more diverse, just like we expect.
Right.
For them being the originating population. And go ahead.
Oh, sorry. Are just to be clear, are they saying, like you brought up recombination, are they actually saying recombination causes mutations?
Yeah. Kind of, yeah. Causes
they are really saying that. That's just dumb.
Just patently wrong. Okay, let's see. Oh, yeah, there are 30 different definitions, and they're talking about how this is a superior method. So they're touting this as a superior method for identifying species.
Right.
Basically.
Yeah, that's the context of the paper.
Yeah, and it is. And I don't know. Oh, let's see. Forget what else. Toward the end of the paper here, they have the part where they talk about 200,000 years, I think. Let's see, is that at the very end? Let me see. Okay. Simple hypothesis is that the same explanation offered for sequence variation found among modern humans applies equally to modern populations of essentially all other animal species. Namely, that the extant population, no matter what its current size or similarity to fossils of any age, has expanded from mitochondrial uniformity within the last 200,000 years. And that tells us something about species and speciation. That doesn't tell us that everything jumped off the ark 6,000 years ago. But that's where they want to go with this, right?
I mean, that brings up a related question I had, which is, like, I keep bringing this phylogenetics to them, and they keep mentioning, oh, there's genetic data that makes that irrelevant, like these genetic boundaries that show they can't be related. Does anyone know what the heck they're referring to?
Something they pulled out of their ass.
Okay, they talk about what, genetic boundaries?
Yeah, I mean, like you brought up humans and apes, Marshall, and they talked about how there are clear genetic boundaries that show they can't be related.
Yeah, it's I don't know. SFT was talking about how the human Y chromosome is different from the chimpanzee Y chromosome, and the chimp Y chromosome is more, or the human Y chromosome is closer to the gorilla Y chromosome than the chimp, and that proves that they're not related. And then I didn't have an answer for that at the time of our debate, and then I looked it up, and it's actually a really simple explanation. It's just that chimps have undergone rapid change to their Y chromosome. It's just they have. I don't know.
Did it have anything to do with incomplete lineage sorting?
I don't remember that. I don't remember.
I'll pull up the transcript in a minute here. But the other thing I wanted to note is that they also said fossil evidence for mammalian evolution in Africa implies that most species started with small founding populations and later expanded. And that is not surprising. That is kind of the definition of speciation. That these small populations branch off. There's a founder effect and very high likelihood of a single mitochondrial ancestor because of coalescence in that population. So none of this is surprising, but they're capitalizing on it. So let's see, I'll pull up the transcript. Maybe we could find stuff that we want from the transcript. Window, Chrome tab.
Because I'm fairly confident that the genetic boundaries they're referring to are based on phylogenetic methods, in which case, if that does end up being the case, they're using phylogenetics to disprove phylogenetics.
Yeah. So they mentioned boundaries 27 times, so I'm not sure where we're at here. In your model, that's unexplainable because mutation, that is far too fast for species to form in the boundaries and the limits that you have to remember. You have things going into a bottleneck, only a handful and just a few coming out. That's not a bottleneck. Bottlenecks, 1,000, 2,000, 10,000, 100,000 items.
Right. Is this the paper they published?
No, this is the transcript from the video last night.
Oh, okay, never mind.
Yeah, I just translated it. Let's see. Bottleneck, okay, just coming out on the other side, and this is the worldwide killing all fish, killing all birds, killing all land life, and yet what in your model does that just, what the fuck? Transcripts aren't the greatest sometimes.
Yeah.
There's nothing but then the way they talk isn't the greatest either. I mean, if you listen to Raw Matt, the transcripts are sometimes clearer than what he's actually saying. This is bizarre, and I don't know what to do. Let's see. Okay, I'm not sure. Well, let's go look. I want to see where they're talking about this boundary. Clear genetic boundaries, and there's not much in between if the individuals are stars. Okay, so they're talking about. They're talking about this one gene, that it has really clear boundaries between species that allow them to barcode it. And so they're kind of making a big deal out of what this one gene does.
Wait, so they're just looking at differences in one gene.
Yeah.
Isn't that, or go on.
No, you go ahead. Hang on a second. I want to check this out.
At first, that kind of sounds like I said, how phylogenetics works. At least like distance-based methods like neighbor joining, which I think I actually saw a graph about that in the paper they were talking about, like about pairwise distances in the actual 2018 paper.
Yeah. Let's see. Pairwise differences.
So that kind of made me chuckle. Like they came to they came to some conclusion using phylogenetics. So if you're going to use that to say there was no phylogenetic pattern, then you're kind of going in a circle here.
Okay, they're making a big...
So what they're saying is that there's too much difference between species between between families, or what is it?
Oh yeah, they're
But
talking about this COI gene, right? And this paper talks about the COI gene and how because of the fast mutation rate and the amount of synonymous mutations that are possible, that they can use it to identify a species, and that in between species there are very clear gaps. Okay, but this is this one little mitochondrial gene that they're talking about. This doesn't apply to other genes anywhere. This is why they're using this one gene, because it turns out to be a nice little tool so they can barcode species.
Right. Yeah.
Because sometimes they can't tell the difference. The male and the female are so dimorphic, they're so different that they can't tell if they belong to the same species until they barcode them, and they're happy with their technique because of this, right? So they're kind of like trying to extend this to all of genetics. And
right.
I
mean, like the nuclear genome is a lot more complex than the mitochondrial genome.
Yeah.
And I mean, this kind of gets at like what even is a species, right?
Right.
Like if they are too close, it's not saying that like everything is completely different. It's saying like if they're closer, then we shouldn't consider them separate species.
Yeah.
Right. I mean, it does get a bit fuzzy because like how much difference counts.
Well, species are a fuzzy thing.
Yeah.
People like to put things in hard boxes, but you can't do that with fuzzy things.
It doesn't work. Yeah, even among humans, there are two different types of this. I think it was not the COI gene, but some ATP synthetase gene, and they found a difference between humans in this one mitochondrial gene. There's been some sort of a diversion, and the two do not mix up. They have to have certain complementary genes in the nuclear genome in order to make it work. So they find differences, basically, even within humans.
Right.
There are differences.
I don't think they understand that individual genes can be very discordant with other genes in the analysis.
Yeah.
But what they're like, they even mention is how you're looking at the major patterns and you're not looking at the specific details. Well, yeah, but like you gotta look at the data overall, because if you're looking at one particular gene, those individual genes can show lots of incongruencies. But we understand the mechanisms behind that, and we're trying to correct for it. So just finding one gene that's kind of an outlier, and or even a few genes that are outliers doesn't. I wouldn't say it doesn't count, but like it doesn't really matter as much when like you have thousands of other genes and species trees that are congruent, which is my point.
Yeah, for that ATP synthase that I was talking about that they mentioned in the paper, you could almost make a case that you had two different species of humans or subspecies based on that, because there's a difference. You could, but do you wanna? I mean, we're not that worried about where the species boundaries are.
Right. I mean,
no one is.
Well, I've actually read that paleontologists or paleoanthropologists will admit that we do make more distinctions for our own line than we do with other species.
Oh yeah.
And we just because we want to know more about it, so we do make finer, or we you know what I mean, like we make finer distinctions among human ancestors than we would among other species, just because that's what we do.
But there's nothing golden or required about the word species, and about the definition of a species. Now that we have genomes, that's not how we think anymore at all. There are gray areas right from one end to the other. So, it just doesn't matter anymore.
And ring species.
The only time it matters is if you're out in the woods and you want to identify a species of plant, so you can decide, whether you want to eat it or not.
Yeah. Or if you're a game warden and you want to know if somebody shot a wolf or a coyote or a hybrid.
Right. Yep.
Oh, Demeter is here.
Hi, Demeter. Different species can't
11th
crossbreed.
dimension says, yeah, that's not true. That's the biological species concept.
Yeah, that's one definition.
Most biologists don't hold to that anymore.
Nope.
The problem with that is, for one, it's useless when you're talking about asexually reproducing species.
Yeah.
And for two, it would force you to conclude that polar bears and grizzly bears are the same species, coyotes and wolves. There's so many species can interbreed, but don't often in the wild.
Yeah, I think the best way to go about it before we move on is basically use the species concept that will make the most sense for the particular problem you're trying to solve. I mean, that's kind of all you can do at this point. There is no steadfast, universal definition of a species. There just isn't.
Right. There's multiple species concepts.
Yeah.
You see what I got highlighted here, Andrew? Your
What?
name. Got your name highlighted.
Oh, yeah, they mentioned me.
In the transcript. Let's see, I'm curious, it's your thoughts, people in the chat, like Andrew, who puts a lot of effort into those phylogenetic trees. So when we were building these trees, let's see, various traits and morphologies, and look into species trees and gene trees. We even look at the amino acid trees. What are those? Well, okay. What does this say about their conclusion, since they assume evolution to prove evolution? Okay, yeah. I love that line.
That's just wrong. I mean, it is true in a sense that phylogenetics does assume common descent, but that is because of the fact that common descent was established before phylogenetic methods were established. So,
I don't know if you knew this or not, but we assume chemistry in order to prove things in chemistry.
Right. Yeah, you don't go back to that. I think I said that either in the chat or I've said it another time. If you're going to post a paper about dealing with C. diff, you're not going to go back to reestablishing the germ theory of disease on that paper.
Right. Otherwise, you wouldn't get anywhere.
Like, if we're doing chemistry, what the hell are we going to use but the chemistry to decide what is going on? I mean, it's ridiculous.
I mean, that isn't to say that those things are necessarily set in stone, just that they're not going to be overturned overnight.
Yeah.
Right.
Hi, Amy. Hi, Chris.
Amy.
Hi, I've been not watching the chat. I'm sorry, guys. I'm a bad person.
You're good.
You're good.
I'm bad.
I want to say hi to everybody in the chat. Love you guys.
Anyway. Okay. So
anywhere did they actually... Oh, sorry.
I wish I'd watched more of this, but I don't have that much hair left.
Yeah. I mean, do they ever, really define what they mean by boundaries? Did they even talk about it really in detail? I'm guessing.
Well, let's see. Okay, they mentioned it a hell of a lot. Okay, boundaries. We see genetic boundaries and genetic diversity levels in the COI gene through barcoding. That is contradictory to the universal common ancestry. Why? No, it isn't. It all makes perfect sense to me. I don't understand what they're talking about.
Like I said, I think one incongruency here disproves the whole thing down here.
Yeah. Okay. Fact that what humans and non-human apes are not related. We see boundaries, and it's just not possible. What are your thoughts on that, brother? Why do they call each other brother? That's kind of creepy.
That's a Christian thing.
It's kind of like kind of reminds me of Shriners. I always thought they were creepy. I used to run away from those guys when I was a kid. When with their little cars in the parade.
It's because if they call each other brother, then they can that makes it so they won't think about each other in a sexual way. I'm assuming, but
okay,
yeah. For them. Yeah.
Yep. It's not possible. What are your thoughts? Okay, I know you spent a great deal of time on taxonomy. Raw Matt? So, right?
Raw Matt.
Yeah, he spent a great deal of time on taxonomy. So right now I was showing that earlier.
I'm pretty sure Raw Matt is the same guy who said like
he's a fruit bat.
They would classify skunks differently based on different traits that are irrelevant to phylogenetics when you really look into it, like on their intelligence or I forgot what he mentioned, but like just the way he mentioned it was just
yeah.
so...
Yeah, I don't remember. He said something about that. So just like what? Like they have no idea how it even works at all.
Or maybe it was raccoons. I don't know.
Okay.
Yeah.
Oh boy, I just spotted a thing in chat where you said I like you too, standing for truth. Are you guys like getting together later?
I mean, I've had a talk with him about doing another debate on his channel.
Yeah, he is a decent guy to talk to, particularly backstage. Yeah.
I'm personally reconsidering debating SFT.
Yeah. Are you? Well, you're going to, right? Or you're supposed to? But
I'm supposed to, but I'm reconsidering
because he's been jerking you around on it.
Just because, like, I know it's a debate and all that, and no one's gonna change each other's minds. But like, why do I need to put effort into it for someone who doesn't even want to listen?
Yeah.
Well, the whole point of the debate is to convince anybody that might be watching.
Yeah, I know. I find it hopeless is all.
Yeah, but on his channel, you're going to find two kinds of people. You're going to find the kind that are super chatting, standing for truth, and there's no reaching them. And you're going to find a smattering of us. Right. And we don't need convincing.
Yeah, that's true.
So what are you getting out of it? You know, it's just, I don't know. I just don't see the point.
I'd be open to do a tag team debate with you if we could get something like that set up.
Yeah, I'd be happy to do that too. I don't feel like it would happen.
Right. I got you.
Okay, the only way that you're going to manage a debate with him, and I will state this publicly, and of course he will hear this, is to hold him to one single topic and dig deeper and deeper and deeper into the papers, into the science, and watch him fall down and watch him get angry.
Right.
If you hold his feet to the fire on one single thing and don't let him dart all over and do his gallop.
I think oh, sorry.
He even brought up chromosome 2 with you, right, Marshall?
I think so. I don't remember.
Yeah,
I'm sure it was part of his Gish Gallop. I actually tuned out most of what he was saying. I had a headache that day anyway, and it just listening to him made it worse. So
yeah,
I feel like in the chat, I think he's picking up on some of the terms I'm using, because like I mentioned phylogenetic signal again, and he said there have been lots of I don't remember exactly what he said, but he said there have been lots of arguments that have refuted the high phylogenetic signals and this and that, and I was like, I don't think you know what I'm talking about.
Yeah,
I feel like you're just
he's almost like a chatbot.
Sorry, what was that?
I said he's almost like a chatbot. Like he's really good at like parroting words that sound scientific.
Yeah,
very good at avoiding actually learning it. Yep. What am I looking at? Oh, hang on a second. I was gonna pop the video up.
Oh no.
There. What am I looking at? What is that diagram? Maybe I can make it. Well, I kind of want to see the chat too, so I don't really want to go. What is that diagram you're showing?
I think it's comparing.
What the hell is this? Well, let's see.
That's the worst graph I've ever seen.
Yeah, what is this graph? What the? You can,
Oh!
hang on.
Oh yeah, he was talking about how it was something about orangutans and gorillas and all the different apes and saying that orangutans are older than
Oh
humans.
yes, that was
I,
hilarious.
I think they misunderstand divergence time and how old that particular species actually is.
Right. I mean, like the tip of the branch doesn't equate with the branch point.
Right.
What is what is the bar at the end?
Orangutan.
It says max diversity.
Oh.
No. Okay. So, is that supposed to be an orangutan?
Might be a given.
Denisovan. I don't know what the hell that graph is. I don't know where that graph came from. Did he source that one?
No, he made it. I think.
Humans. Okay. Minimum, maximum. Neanderthal, max. I don't understand his headings at all. If somebody made that, they didn't do a very good job. Bottom, mankind diversity. Ape kind diversity. The ape kind.
Well,
that's terminology.
That's definitely a creationist site, right? Yeah. I don't know where that one came from. I'd have to dig that one up. I wonder if I look up ape kind diversity, if I can find it in images.
What's funny is one time I saw in his debate with Gutsick Gibbon, she pointed out that there were just as many orphan genes between chimpanzees and gorillas as there are between us and chimpanzees. And then he's like, well, it must, maybe chimpanzees and gorillas are a different kind.
Yeah. Yep.
They can just switch around what they call a kind anytime they want.
Yeah. No, I do not see that graph anymore. Let's see. The ape kind.
Huh. Like the pagan mom says, wouldn't we be an ape kind? You're actually
we're obviously
correct
not.
if they didn't use special pleading.
Because we're obviously not apes. Why would anyone think that?
Oh, I'm going to search for more. Let's see. Ape kind. What else do they have here? Humans minimum diversity. It's good to look up where they get these illustrations from sometimes.
Yeah.
It's very telling, when you find the answers in Genesis site that they went to, or Creation.com site. But on this particular one,
SFT has his own website too.
Oh, really?
Does
he?
Oh.
Yeah, go to the about in his YouTube. It's like creationistclothing.com or something like that, but he also has articles on it.
Oh, I thought he just sold. I thought he just sold T-shirts.
No, he also posts articles.
Oh, okay. So on his merch site, he's got articles. Interesting. I will have to check that out right now.
So Speed. If you have anything else to go over, we can. But when do you want to open it up to?
We can open it up if you want. Sure. I'm probably going to take it back.
I'd like to stay on the topic of evolution and phylogenetics if anyone comes in, but we'll see what happens.
Yeah, I'm not feeling particularly well, so I may mute myself and let you guys have at it.
Okay.
How'd your surgery go?
Pretty well. Actually, it was kind of like going to a Pink Floyd concert.
a lot of lights.
Yeah, a lot of bright lights and flashy things, and over the process, as she went around my iris digging a trench with a laser, my eyes started to ache and feel very warm, which kind of worried me. But anyway, other than that, it wasn't painful, and it was I was in and out of there in a couple hours. But I'm pretty. Yeah, my sight is kind of coming back in my left eye now already, which is kind of cool. But it causes the eye drops they give you cause a pretty wicked headache because it messes with your eye pressures and stuff. So I'll survive. And we'll find out in 3 weeks if it made a difference. and then they're going to do the other eye.
Oh, they only
Okay,
did
guys. Huh?
They only did one eye.
Oh yeah. If they did two, I would have been really messed up. So
Oh, that makes sense.
yeah, they're experimenting on me, and if it works, then they'll do the other eye. So we'll see.
Oh, they're
Okay.
gonna turn you into a robot.
We got to keep me from going blind because I got a lot of weapons here, and it's very important that I see.
Oh,
Right.
Don't you? Yeah.
Has Chris Peacock ever been in here?
I don't think so.
Hey, Chris, you want to come in? I'd love to hear from you.
Yeah.
Hey,
We're
Jay.
always high-fiving each other in the chat. Hey, Peace Junior.
Hey, how's it going?
So, what do you think of everything so far?
You mean with the stream?
Yeah.
Yeah.
I think it's pretty typical SFT. I feel like he likes to just say things have been refuted and leave it at that without really, he says that and you're like, wait a minute, when was it refuted?
Yeah. When did you refute
Right.
anything?
And like he'll respond to Erica with a 7-hour-long video where it's like Erica's destroyed, she's now homeless and destitute, she's begging for money.
Yeah.
But and then you watch the video, you sit through it, and it's like you didn't refute anything she said.
To refute something, you must
Yeah.
first understand the something, and I don't think they
Yeah.
understand it.
Yeah, and speaking of Erica, she just got her thesis paper approved today.
Oh,
Oh, sweet. Congratulations, got sick after you.
She has a
Congrats,
master's.
Erica.
She has a master's degree now. So SFT, because I don't know if you saw when she would play video games on her stream. There's a game that's about anthropology and human evolution. I forget the name of it, but you play as an ape and you
Right.
can advance, through like Sahelanthropus chedensis and different species. And she was doing these gaming streams, and then SFT told her one day, he was like, when you're done playing video games, you can come talk with the adults or something like that. And I thought that was really
Wow.
lame. And because she talked about that in our interview, and she was saying, well, I only started doing video game streaming after I finished my thesis for my master's degree. And so how is the Amazon book section, SFT? Which I thought was funny.
She's awesome.
Yeah, I did a great interview with her on my channel. If anyone hasn't seen that, it's really good.
Yeah, I'll second that. I got my in case anybody hasn't noticed, my YouTube name, Monkey for Banana, is actually Erica's nickname for SFT.
Yep.
Yeah, she
And
came up with that nickname for him.
Yeah, and I got permission from her to use it. So.
Yep, I saw that.
Yeah, she came up with that name, and then in our talk is when we started saying like MFB for short, which is funny because it rhymes with SFT.
Right.
Should I come up with my own nickname for him?
I think his is already established.
Yeah, that's true.
Oh, I see. You've got a 4 emoji.
I mean,
I see. That's funny.
There's also Strangling the Truth. I think Feed uses that one.
Yeah. Well, yeah. I wouldn't want to just be like Strangling the Truth or standing.
The one I had was Sitting for Lies.
Oh. Yeah, I don't want to be too mean about it, but I want it to be. I would want it to be kind of intelligent, but also creative. You know what I mean?
Oh, well, then you're gonna have to come up with it on your own.
Yeah.
Because all we got is childish stuff.
Yeah, I would just stick with the MFB.
We only do creative here. We don't do intelligent and creative. So.
Oh, I didn't know that, Speed.
Yeah, that's the way it is. I'm trying to find an article, the article with the picture in it, but I can't.
Oh,
human origins. Here we go. Maybe that's it. Chapter 1. Oh, it's his book. He gives away a free chapter of his book on the website.
So
Yeah.
Sorry.
Oh, I wasn't saying anything. I was just saying, yeah.
So Atheist Junior, what do you think about the like they keep doing this where like look, it's a phylogenetic incongruency over here, but then ignore the the vast number of congruencies that outnumber those.
Well,
Like there
I
are
think
lots
that,
of incongruencies, but like they're increasingly becoming the rarity, not or yeah.
well, if in phylogenetics they notice some sort of incongruency or they notice some sort of mistake that they made and they're able to correct the mistake, then that's a good thing. Like when they first started organizing animals they used morphology before genetics was discovered,
Right.
and then once genetics came around, there were some very counterintuitive examples where animals that seemed like they were closely related had to be put in different taxa because the genetics told us what the absolute truth of it was. And so this is a mistake that creationists commonly make, is they seem to think that, like, for example, with the Big Bang, like, or the age of the universe, the fact that the date changes, they seem to think that science getting a more accurate result shows that science makes mistakes. But if you make a mistake and then correct it, that's a good thing. That's not something to be criticized for, versus
Right.
religion or creationists who have been using the same arguments for decades and never changed them.
Science
oftentimes-
learns, creationism doesn't.
Yes.
Right. Well, oftentimes what we see is, instead of a completely new tree being made with genetics, what we usually see is there were two competing hypotheses based on morphology, and then genetics confirms one of those two hypotheses. Like
Yeah.
with bats, at one time it was argued whether bats were more closely related to primates or more closely related to other insectivores. And then genetics confirmed that they're more closely related to things like shrews and hedgehogs than to primates.
Yeah, I
Yes.
think I heard that too.
And then in the Bible, you had bats sorted as either birds in one section or as locusts because they swarm, because the Bible sorted animals based on what they do and not like what they are.
Right.
Right.
It grouped them by overall appearance.
Like creeping things or the beast kind, That's
Yeah.
why they thought whales were fish. And I can understand thinking that whales would be fish. It makes sense. It's like creationists like Ken Hovind, they like to appeal to common sense. And common sense, but the thing is, the common sense would tell you that a whale is a fish. A common sense would tell somebody who goes out and looks at the horizon that the earth is flat. And if that's the only evidence you have, that's pretty good evidence that the earth is flat. But you need more evidence than that to show the actual truth of it, because sometimes the truth is counterintuitive and it goes against common sense, and that's where science comes in.
Right.
Right.
And just to be clear for the audience, phylogenetics isn't based on what in this case would be called phonetic similarity. It's based on explicit models of character and mutation rates and DNA evolution and stuff like that. So it's based on things we can observe and just extrapolating that out into the past, basically.
Yeah,
Find
like
deeper and
a
deeper relationship.
creationist would accept that a family tree means that they know they're related to their family. Well, you're only related to your family because you have a high percentage of DNA similarities with them. Well, we have a high percentage of DNA similarities with chimpanzees. And then you look at like mice, and we have less DNA similarities, but we still do. And then you look at like, moss, or like, what is it, like,
Nematodes?
the stuff you put in bread to make it rise, yeast.
Oh, yeast.
Yes.
Humans have a small percentage of DNA similarity to that. So, it's just about the percentage. And it's like they simply pick an arbitrary point where the percentage is not high enough and say we're not related to them anymore. Like Kent Hovind talking about, they say chimpanzees are 98% similar to humans, but really it's like 92%. And that's only because there are different ways of examining the similarities, but it's like, well, what percentage would be high enough for you to say that we're related?
Right.
Yeah,
Oh, sorry, go ahead.
That study was extremely flawed, where they got like the 88% differences. I think we've been over that study enough times. Like that's.
Yeah.
I think
The method they used would be basically like if you're trying to compare if two books are similar, and if you find one word that's different, then you conclude that the entire chapter is different, or everything after that word is different, even if it's just that, because they would.
Hey, Chris.
There's different ways of counting it, and they were not doing it right.
Welcome. How are you?
Hello.
Hey.
Can you hear me?
Barely.
Yeah, a little bit. Can you turn your volume up?
So I don't know what music.
Is this thing on?
This is the first time I've done it, so
Test 1 2.
testing. Yeah.
I turned you up to 100. So.
All right. Can you hear me, Sal? No.
There we go.
Yep.
Yeah. All right. Great. Hi. My first stream. Thank you.
Yeah, I always appreciate your comments and your positivity in the chat, Chris. Thanks.
Positivity, bloody hell. Right. I try not immaturity to me.
Yeah. So what do you think about this phylogenetics and evolution stuff SFT is going on about?
Oh, I just spent an hour in there with the amazing geologist and talking whale bones with pigs and fly. Just put my head in.
Apparently, that guy actually is a real geologist. I looked it up.
Who
was he?
The guy that SFT has on there. What's his name? Doctor. Not Doctor.
McQueen.
McQueen.
Yeah, McQueen.
Oh,
yeah.
Okay.
Oh, Dr. Crackers.
Mr. Plasticine and Crackers. Yeah.
Yeah, there's we link something in the description. Fringula does a little bit on here. I think it's on Snelling, but it's the same idea. They're talking about how rocks can't possibly fold without cracking, which just shows that they don't know the first thing about geology.
Well, yeah, try that about.
I saw a video of a rock that can actually bend.
Yeah.
Very little, but it is flexible.
Well, a lot of earthquakes because rocks bend, aren't they? To get trapped on the subduction and then bang, they spring out. That's them bending into. They don't crack.
If you change temperature, pressure, or time, everything becomes plastic.
Yeah.
Wait, rocks turn into plastic?
Yeah, they behave like plastic over.
I know. I'm just messing with you.
Okay. Oh, I'm sorry.
Turn into plasticine or crackers.
Sorry, my humor is not readily accessible tonight.
Yeah, my humor is terrible.
I got into an argument with somebody on Discord where they were explaining it correctly about why the Earth has a magnetic field because of the iron core. But then they started saying that the pressure inside of the Earth turns everything into metal, into iron.
Did you guys summon me?
And
I heard rocks.
Hey, okay. Rocks.
Yes,
Get your rocks off.
Do you want me to throw some rocks at you?
I have some rocks I'm going to put under my microscope for you. I was standing outside the eye clinic waiting for my ride today, and I stole. You know how they have rock, for rock landscaping.
Oh yeah.
I stole about 10 of the rocks.
As you should.
As I should, yeah. Nobody else looks at them, What the hell? I brought them home and put them on the table, and my cat was totally freaked out by the rocks. He's like, "What are these?"
Nice.
Thought they were going to kill him.
Oh, sorry. Jorge, did we ever talk about geochronology?
We have not recently, no.
Oh, okay. Would you want to talk about it now? I guess if Speed's okay with it.
I can if I'm useful, sure. I'm not on for super late, but I can do something maybe, hopefully.
Andrew was kind of wanting to keep the stream more about phylogenetics and stuff.
Oh, yeah, we should probably do that. Okay. Thanks, Marshall.
No problem.
Is Andrew even here?
But it was Andrew that just suggested we talk about geology.
Yeah, that's what I
my
thought.
bad.
I thought Rational
Okay,
Empiricist was Andrew.
I wasn't trying to speak for him. I was just
Yeah, I mean, it's up to you, Speed. Should we keep going on phylogenetics, or should we do a little bit of geology and maybe end the stream in a little bit?
At this point, we can do whatever you guys want to do. It's a playground.
I want to know why
You're-
Marshall hates rocks so much. That's what I want to know.
Yeah.
oh no, I like rocks.
Marshall hates rocks. Rock hater.
Sometimes they're just
Logic
aren't
doesn't like rocks.
rocks.
Rock
So
hater.
Jorge. Oh, sorry. Oh, so Jorge, what's your I guess favorite geologic era to start with?
I've actually asked that question in some of my classes. So I did magnetics work. We try to look up because I worked in epochs, not in classical eras and periods and stuff like that. But
okay.
the origin of the magnetic field, that era of geologic history is super interesting. I can try to find the term for it.
Okay. Would that be in the Archean?
Yeah, that's way before life. Yeah.
Okay.
Let me try to find the exact. It's been a while since I've had to use that stuff.
I think someone's echoing. Is it just me?
I think it's just be you. I hear it too, though.
It's Chris, I think.
I hear
Oh,
myself
shit.
echoing too.
Right. Well, I'm going to head out now, pal, because it's 2:45 in the morning here. So I'm going to hit the sack. Thanks for being, so
Yeah, nice.
inviting me in.
Thanks for coming in.
Yeah, thanks for stopping in.
All right.
Yeah,
Cheers.
thanks, man.
See you later. Thanks a lot.
Meet you.
Okay.
Have a good night.
Yeah, good night.
So what were you saying, Jorge?
Oh, I'm trying to figure out the naming convention for the epochs. It's not unusual maps, but yeah, Precambrian, probably Archean age stuff is real cool because that's when like everything was forming and spreading by mass and all that. That's really sweet. Geology didn't do a whole lot interesting after the sort of formation of the planet. So outside of your giant traps and stuff like that formed. So that'd be geologically speaking, that's where like the fun happened,
Oh yeah, that I just remembered another question I had for you, but it's more about plate tectonics.
Yeah.
So when geologists refer to mantle convection, are they referring to the general process of heat exchange and gravity and all that, or are they referring to the mantle dragging the lithospheric plates along specifically?
My understanding of mantle convection is the conveyance of heat from the core out to the crust. That's my understanding of it because the convection is driven by that, and then the slab push, slab pull is in response to that convection, which then drives it on. So slab push, slab pull is like a tertiary event in this chain that eventually has it all happening.
Right. I think a good way to describe it, and a professor gave me this once, would be stuff's going up, so other stuff has to come down, and vice versa.
Yeah, it's kind of like how a lava lamp works, to be honest. That's analogous to what's going on there. Lighter stuff goes up, heavier stuff goes down, and the energy release is what's driving that entire cycle.
Right. So do geologists know if it's ever gonna end per se?
So I will couch everything, and it's all speculative. We don't have any definite answers, right?
Okay.
We have good reason for speculation, but no, 2 + 2 = 4 levels of certainty here. The inner core is considered, I think it's iron and nickel, I believe. I can't remember the exact percentages, but it's radioactive. So we're basing the heat output on how radioactive the core is and the amount of heat that would be given off by the radioactivity of something that large.
Right.
I think the sun's going to blow up before the Earth's core stops producing enough heat to cause any significant issues.
But before Leo starts jumping in, I do have to correct you. The sun isn't going to explode.
Well, you know what I meant. Like before the sun,
I know. I wanted to make it clear for Leo.
Yeah, I suppose. Yeah, he is very anal about those things. So,
But
So
anyways,
I have a question.
okay.
Is it actually so what causes the Earth's magnetic field is from iron that's not liquid, it's solid, right? And is that at the very core of the Earth, or is that the outer core?
So, creationists get this wrong a lot, so I'll try to explain the process. You're familiar with the put a coil around a magnet, and then like if you move the magnet, it produces electrical charge in the coil, right? And therefore magnetism.
Yeah.
So
Yeah.
you usually think of that as moving the magnet, but you can also move the coil and have the same effect, correct?
Right. They're like equally they're like at counter angles to each other. The electricity wave and the magnetic wave are kind of equal.
Yeah. So it doesn't matter which one you move as long as one of them is moving. So what's going on is the iron inner core is essentially the magnet, if you will. And then the convections around that is what is the moving of the coil. So the magnet isn't moving, the coil is moving. And that's what's producing the magnetism.
Oh, it's not the spin of the Earth?
No, the spin of the Earth has nothing to do with it.
Oh, I see.
The spin of the Earth is, completely separate. The magnetic field changes all the time, but the spin of the Earth does not.
Yeah, I thought that the Earth was turning and the iron core was turning, and that's what caused it. I guess I was wrong.
No, it is the rotation. Again, all couched in theory, right? But good theory, good evidence, and good reasons. The convecting, moving, plastic-like material of the lower mantle, outer core, stuff like that area, that movement is moving around something that is strong and iron. And that conveyance of movement, essentially the moving of the coil around the magnet, causes the electricity, which then has the byproduct of the magnetism.
Something else that I think I have this right. If you get a copper tube and you wrap a coil around it, and then I don't know if you have to run a current through it, but then if you drop like a metal piece through the tube, it'll fall slower than if you just dropped the metal through the tube normally.
Yes, 100%.
Yeah. I think you just have to wrap a coil around it, and that's it.
Yeah, because that movement, that awesome idea of how like electrons, like I kind of describe it when I teach introductory physics as if you picture in a wire all the electrons as like little marbles just all touching each other, and then if you move one marble, you technically move the string of marbles. And the movement of that string of marbles is actually electricity. Like electricity isn't using electrons, it's moving electrons.
Right.
Right.
So it's kind of like a bunch of little magnets, in this case, the atoms that are moving around and creating this overall magnetic field, right?
Yeah, exactly. And the magnetic field is what we call not monopole. Oh my God, I'm losing the word. No, we model the magnetic field as a dipole, but in reality, it's there is no way to model it with any particular magnet because it's constantly changing, evolving, and there's magnetic parts going out
Dynamic.
and magnetic parts coming in throughout the world, constantly evolving and changing. So, oh my God, what's the word? Not unipole.
Dynamic.
Well, it's very dynamic. Yes, that would work as well.
Dipole.
If you look at a current magnetic field of map of the world of the planet, you have technically North Pole parts in the South Pole where like the mantle is just weird down there, and it's producing outward magnetism where the southern has like inward magnetism, and it's constantly changing. That's like what a magnetic field flip is that sort of dynamic. It's super ridiculous to watch in real time.
You know how we can track the flips throughout geologic history, right?
Yeah, I did that.
There's
research.
a signature in the rock that was laid down from volcanic lava.
It's called remnant magnetization. Yes,
Yeah.
I did research in that. I worked in a lab that did that stuff, and
That's what I was going to say. I thought that you focused in that area.
I did, yeah.
Yeah.
And you can use different remnant magnetization sweeps, thermal or what have you, ARG, what have you, and you can essentially like wipe time off of the magnetism and see the rock's history in the magnetic field over time. And it's so super sweet to do because like you can sweep like half the magnetism off and see what it was like halfway through its cycle, and then sweep more magnetism off as it goes down later and later. And that's how we know how it develops.
I've heard Kent Hovind say that like, oh, there've never been magnetic reversals. It's just stronger and weaker magnetism. Like,
oh, very incorrect.
That's obviously wrong, but what would you say to that?
Well, something you can derive from reading the magnetic signature of rock is inclination. And that tells you what is north and what is south. So if we currently have, like our North Pole is the southern end of a magnet. So we have inclination in the northern hemisphere that's pointing down as the magnetic field lines are entering the North Pole. And that's called normal magnetization. And you can find rocks in the northern hemisphere that have reverse inclination, wherein the inclination's pointing up like what we have in the southern hemisphere. That is a reversal because do you know what inclination is, if I say that word?
No. Hey, Marshall, I think you have some background noise.
So declination is like your left-right. Inclination is your up-down.
Mm-hmm.
And you're talking about, are you talking about movement?
No, I'm just talking about like, well, yeah, there's movement, but a rock captures that photograph of that movement. So because
there's metal in the rock?
It's more complicated than that, but yeah, it's more complicated than that. But
when you say you're looking at the inclination and declination, you're looking at how that rock has captured movement and which way the movement is. So
to give an example, if you go up to the if you go up right around the Arctic Circle, you have very high inclination because the field lines are very vertical.
Oh, okay.
And then if you go down the equator, your inclination's almost at zero because the field lines are very horizontal.
Mm-hmm.
Right?
I got you. Okay.
The short answer of how we tell in the rocks is that the magnetic field makes the crystals point a certain direction, and we can tell what direction those crystals are pointing.
Yeah, that works. It's not like technically true because the crystals don't actually move, but that works for sake of conversation. Yeah, no reason to go any deeper. So yeah.
Right, if you were on a ship, and you had like a compass, and you were passing over the seafloor, and you were going from one area that had a magnetic reversal to the next one, would your compass point north in one area and south in the other?
So it's not that strong to affect a ship's compass, but in World War II, they took magnetic measurements of the Atlantic Ocean, and they found exactly that. The rocks are striped in inclination, reversing north-south as you go from the Mid-Atlantic Ridge. That is the thing that confirmed plate tectonics for the geologic community.
So Orge, while we're on, and unless Safety's Junior had another question, but I had something I want to clarify about the mid-ocean ridge and plate tectonics since you mentioned it.
No, I didn't have anything else to say, although I would just add that I believe plate tectonics wasn't confirmed until long after the person who discovered it had actually died.
Correct. Wegener died in like the 20s or something like that, and World War II is when the geologic community accepted it.
Yep. So my question, and I feel like this is a dumb question, but like, so you have your continental crust and oceanic crust, and oceanic crust subducts under the continental crust because it's denser.
Yes.
So if that's the case, and it always subducts under the continental crust, how exactly are the continents moving? Like, wouldn't it just be like staying in the same place, or am I imagining this incorrectly?
So we say subduct, but I think you're picturing it as a complete subduction when you do have the continents running into each other. Right? It's not that they're floating on top and the other one's completely underneath. They all smash into each other. That's earthquakes and stuff like that. Happen that way.
So
first of all, and then secondly, you do have the mantle convection currents underneath continents as well.
Okay,
so they're pushing into each other, and they're also convecting right along on their own currents.
Right, because I was imagining it as basically oceanic crust attached to a continental crust. So as the oceanic subducts, it kind of pulls the continent along. Am I imagining that incorrectly?
Let me.
Most of your oceanic crusts are separate from the continental crust. They're separate plates.
Yeah, you do have plates that have both. I think Juan de Fuca plate, like over like California, is like both of them. It's not like they're not perfect separations by any means, but it's the true answer is it's a combination of all that, right? The actual systems are very complicated, and you don't simply have one high school level physics explanation is the same as the real world scientist explanation. So,
yeah. Andrew, I just wanted to say there are no stupid questions, only stupid creationists.
Okay. Well,
I'm sorry. To answer your question more severely, it would require background in this stuff that I don't really think either of us want to cover right now. You know, like I would need like
Thunderfoot
a slideshow.
has some good videos on this.
Like Nick Center does stuff too. If you want to dig in deeper, definitely all that stuff works very, very well. Or just find a university, geophysicists put on these MIT and stuff like that does this stuff too. So,
but like you understand what I'm trying to understand, right?
You're trying to understand the interplay between the plate systems, right?
Right, yeah, like because we know supercontinents form and then they drift apart, and that kind of forms a cycle. But like what I'm trying to figure out is we understand how the oceanic crust subducts, but like if the continents make up their own separate plate, how exactly are they moving?
So
same way.
Yeah, first of all, they're all riding on convection currents in more or less the same fashion. Secondly, you do have plate development, and you do have divergent plate boundaries within continental plates. The African plate, they see that blue line going through it. That blue line actually cuts a bit more to the west and is cutting the Horn of Africa off. Africa is actively diverging right now. And the Red Sea is like expanding as a result.
Is it true that there's a large plate that's sort of like crashing into India by the mountains and that causes earthquakes? Or I thought I read something
that
like
is India. The Indian subcontinent is on its own plate, and that's what's forming the Himalayas. India used to be way further south.
By Madagascar. It used to be an island. Some 60 million years ago, yes.
Wow.
So, Andrew, hope that kind of makes sense in that the plates kind of are going to do what they want to do. In a very simplistic term, you have subduction and divergent, convergent, transform boundaries, but they all kind of develop the way they do. And then you have mantle plumes coming up and all these other things kind of appearing where they choose to appear is the best way I can describe it. I'm sure the mathematics behind convection currents is it's sort of similar to trying to use a computer to figure out turbulence of like water currents. Like we just can't figure it out well enough to guess to do this stuff 100% accurately.
The only simple answer is that it's complicated.
Okay, yeah, I'll have to look into it.
Yeah, I'm sorry I'm not quite understanding the question super good.
I think.
Can I try rephrasing it, maybe?
If you want.
So if you look at this diagram, like it shows the arrows, or someone else brought this up, but like if the say you're near the South American plate, and like, sorry, I'm just thinking because I'm trying to understand this, but it's a bit it's hard to visualize.
Yep, college takes 4 years for a reason.
Anywhere you see arrows pointing away from each other on the ocean, what's happening there is seafloor spreading. You're having new material being formed.
Mid-Atlantic ridge is cutting straight through the Atlantic, hence the name. Yes.
Yeah, and then generally where a continental plate and an oceanic plate have the arrows pointing towards each other. Usually, what happens is the oceanic plate is going to be subducted under that continental plate.
So let's take the Nazca plate and the South American plate as an example. First of all, keep in mind this is a simplified diagram, right? The plates are broken up a lot smaller than this. But the South American plate is being pushed by the Mid-Atlantic ridge to the west. The Nazca plate is also technically being pushed to the east, but much slower because the underlying currents under the Nazca plate aren't as strong as the South American plate. That being said, the Andes Mountains are being formed by the Nazca plate subducting underneath the South American plate because, as you said, continental crust is less dense, therefore more buoyant. So it's an interplay of the push from the Mid-Atlantic ridge to the South American plate, along with the gravity pulling the Nazca plate down and the Nazca plate driving itself in the directions it wants to, in order to have this interplay and this orogenic event of Andes mountain growth and stuff like that. If things continue along this path, the Nazca plate technically could be completely subducted, but in all likelihood, given the amount of time it would take, things might change direction again. And you could have like triple points, all this other complicated geomorphology going on. Does that help?
Yeah, I mean, I guess the way I was visualizing it was like, say you're going up to the Eurasian plate right there, and the western edge of it, the oceanic part of it is being pushed to the continent. Like, how would the continent move if it's I'm trying to like I said, I'm trying to visualize it, but I feel like in some way my question is kind of meaningless.
I mean, so first of all, the plate systems are more complicated in this picture, right?
Right.
You do have the Atlantic Ocean being subducted and altering the continent of Europe and what have you. You do have that on a micro scale, country-sized micro scale, but on a macro scale, the Eurasian plate also has a predominant movement.
Right.
So, if you went to Sweden or something like that and studied the motion of the plates in Sweden, you would have a slightly altered set of coordinates and math than the entire Eurasian plate. But they both would kind of fit together.
And you'll have fault lines all throughout the middle of these plates as well.
Very much, yeah. Technically, the Vatican City is on its own plate. The Pope drives his own tectonic plate around. It's super cool.
Maybe, hey, Speed, can I share my screen? Maybe try using a different image?
Sure, you got a better one? Show off?
I didn't mean it like that, but...
By the way, I think there's somebody backstage wanting in.
You can have 7 in here, can't you?
I don't see anybody backstage.
You can have 10. Well, Tanya was backstage.
Oh, I did not see. Well, he is in and out.
Yeah, that was a few minutes ago.
Okay.
Yeah, Andrew, I do suspect that your questions require more than like a 20-minute conversation as well, you know?
Okay.
So just bracing, as Leo can attest, right? This stuff requires a lot of backgrounding and a lot of study. You know, I got
100%.
this for a reason, right?
That's why the
Alright,
phrase, if you can't explain it to a fifth grader, you don't understand it well enough yourself, is just a dumb phrase, because the more advanced you get in subjects, the more background knowledge you need to have. And some of that background knowledge is more advanced than a fifth grader could understand.
Right, like I think it's basically the same trouble I'm having with quantum mechanics, and the fact that I want to understand it, but I don't have the basic mathematical knowledge yet. So I don't know where to go.
I think geology is probably a lot easier to understand than quantum mechanics.
Yeah.
Just in terms of because we actually can explain most of it. Well,
Everything's more
There's
complicated.
differential equations in geology, isn't there, Oregon?
right.
Oh yeah, I took two
Right, but
past the DiffyQ.
what I'm saying is, like, most of these processes, we as in science actually understand more about it than with quantum. There are fewer
Actually,
unanswered questions.
Well, the second way you worded it, I think I could agree with that. There were fewer unanswered questions in geology than there is in quantum mechanics. But in terms of the level of understanding we have, and this isn't like to dunk on geology, because if it were, I'd be equally dunking on everything that's not advanced theoretical physics. Quantum mechanics is extraordinarily well understood. In fact, quantum field theory, the standard model of elementary particles, is the single most accurately confirmed and consistent model that humans have ever developed. There has never been anything we have ever developed that is more consistent, more accurate, more predictive, and more explicative than that model. And that's because of the rules, I guess, if you want to call them, that reality, quote unquote, plays by. Obviously, I'm anthropomorphizing a little bit. They're very stringent rules. You do very, very, very rarely do you see deviations from rules at that level. So we can use those to confirm things to the 12th, 16th, 18th, 22nd decimal place. And I mean, like I said, we have honed in on these things more accurately than we have anything else. It's insane, actually, how accurate we've gotten.
I guess a better way to put it would be that geology is more intuitively understood because it resembles the actual world that we are used to dealing with.
Marshall, that is exactly one of the phrases I try to beat into my students when I teach intro geology, is that the way that it looks like it's happening is the way it is happening.
Right.
And geology jargon is so nice because it just makes sense. You try to teach biology or anatomy, you're running into big fucking words that you're like, I don't see the connection. But like creep in geology terms is creeping. It's rocks that creep, you know, it's just that easy.
Mm. Well, thanks for helping my questions, Jorge. I appreciate it.
Anytime, man. Anytime. I love taking over streams. It's good.
Andrew, I did have a question for you. What would be the highest level of mathematics you feel comfortable with? And by comfortable with, I'm not talking about, like sitting down and working through problem sets, but like that you feel you have a fair understanding of.
I would say somewhere between algebra and like pre-calculus. Like I can do calculus, but like some parts of it I don't quite understand.
Okay. Because I'm trying to find a good pathway for you to understand quantum mechanics that I think would be swift and intuitively conceptual, to whatever degree you can get quantum mechanics to be intuitively conceptual.
Quantum Mechanics for Dummies.
I don't.
Good book.
It's pretty good, but I wouldn't do that. You're going to want to understand a little bit of single variable calculus and linear algebra. Just like Dessel recommended Quantum Mechanics: The Theoretical Minimum by Leonard Susskind, which I'm reading now. And it's pretty good, but you want to have a basic understanding. It doesn't need to be complex or technical, but the basic understanding of single variable calculus and linear algebra. Vector spaces, matrices, matrix multiplication, matrix operations, stuff like that. I think that for Andrew, if he would go to 3 Blue 1 Brown and watch his
he's very good.
He's got two little, what are they called? oh my god, I'm really drawing a blank on what they call these on YouTube. Really? The things that you can do on your channel that are like series. Wow. I really playlists. There you go. Playlists. He's got 2 playlists. One for
Are they rebroadcasting this on Young Earth Creation on Raw Matt's channel? Is this the same video?
Probably.
Okay. Boy, talk about...
Andrew, in the side chat, I'll post 3 Blue 1 Brown's website. I'll post it to the main guy as well. His videos just
are very
good. They really do. I've used them in public school before. So
I might be able to find the 2 playlists that I'm looking for. There's one on calculus and then one on linear algebra. If you watch those, you have a strong enough conceptual understanding of those subjects to tackle a book like Quantum Mechanics, the Theoretical Minimum. Which for me, for somebody who wants to learn the basics of quantum mechanics, that's the book I'm going to recommend. I really don't think there's a better one.
Thank you.
And they're fun to watch. So he's got like his characters are little pies and they move their hand. It's
yeah.
I don't know what the plural of pie is when it's the symbol, but
so we went from phylogenetics to geology to quantum mechanics. Where are we going next? Astrophysics or cosmology?
Hey, Creation Myths had a premiere tonight. What was it?
Yep.
Yeah, I guess. He did the arc with Kent Hovind. I think he just rebroadcast a debate he did.
By the way,
James Downard is live. In case anyone wants to know. Well,
by the way,
Andrew,
Andrew,
too.
the 2 playlists that he has are called Essence of Calculus and Essence of Linear Algebra. And I've watched those and they're very good.
What channel is that?
3 Blue 1 Brown. Grant Sanderson.
That's a really good
in both chats. So
okay.
Yeah, 3 Blue 1 Brown is really, really good for math.
Yes, Minute Physics might be up your alley too.
Oh yeah, I like Minute Physics and Minute Earth.
Also, PBS Spacetime has a playlist on quantum mechanics as well that's really good.
Oh yeah, I like PBS Spacetime.
Hello. Yeah, PBS puts out a lot of good stuff, like their PBS Eon series.
Yep. PBS Nova. There's a lot. I even like stuff like Frontline and other stuff that gets more, social and socio-political. But then another thing is Leonard Susskind, just really quickly, Leonard Suskind's lectures through Stanford University that you can find on YouTube on quantum mechanics. He's got one on quantum mechanics and he's got one on advanced quantum mechanics whenever you feel comfortable on that one. And that's a really good lecture. And what I'm doing is because his book is based off those lectures. So, and there's 10 lectures in the book and they match the 10 actual lectures that he has as videos. So what I've been doing is reading one of the lectures in the book and then watching it on YouTube. And that's really, really helping me get through this. It's not that I would not understand it if I just read it, but this, it just helps. It gives you a little bit more to work with, and I really, really like that.
What book was this?
It's a really good Quantum Mechanics, the Theoretical Minimum.
Can you tweet it at me?
Wait, what? I didn't understand any of that.
Okay. Can you link it to me on Twitter?
I don't like you tweeting things at him.
Just go to Google and type in Quantum Mechanics, the Theoretical Minimum, and you should get.
I'm on mobile right now.
Can we all just get along?
Yeah, right here, Quantum Mechanics, the Theoretical Minimum, book by Art Friedman and Leonard Susskind.
Oh, Leo.
Hi, Leo. Congratulations on your debate with Sky out. You did pretty good, man.
Thank you.
What debate?
Leo, I wanted to ask you about that Sky out thing. I watched 20-30 minutes and he seemed like a Frankenstein of different more popular YouTubers. I swear I heard LPP phrases and SFT phrases and Neph phrases and Mr. Batman phrases. I felt like watching all 5 of them try to talk at once.
Yeah, I'm surprised it didn't pop out. Well, how do you explain the law of identity, sir?
He was a discount Smokey with his avatar. What the fuck was his avatar? You know what I mean?
Yeah, it's Smokey's avatar, exactly. That makes 6.
Yeah.
Oh, Jesus. Yeah, that was something else. That was an interesting discussion.
Yeah.
I can't wait until we shoot this in the head tonight because I have a thing.
What thing? What do you mean by thing?
I have an outro.
Oh,
I'll shoot myself in the head. I got a storm coming in, so I got to pick the kids' toys. All the kids' toys in the front yard.
Wait,
I got
AJ's
to
not
before
in here
the storm
anymore?
takes them.
Where did AJ go?
They're gonna
I
blow
thought-
away. I don't know. We lost AJ.
Yeah, when did he leave?
I don't
He was
know.
the reason I came in here because he made a
don't
really
know
good
what-
point about electromagnetism that I wanted to expand on quickly, but I guess he's gone. So
I don't know what's happening.
It was not my fault he left. I can say that. So
Yes,
I'm
it
gone.
is.
Good night.
peace
Bye,
out.
Ryan.
I'm gonna blame you.
Did you see my rocks? Oh, wait a minute. Did Roger leave? God damn it.
Yeah, he just
I
said
saw
he was
your
leaving.
rocks.
I don't know
Who
what's
wants,
going on.
who wants to see? Who wants to see my stones?
No,
I'm gonna let you know, Leo.
he's
You
gone.
kick
Save
him for
those
that?
for Emilia Clarke.
They're actually more like boulders, but nah.
Save
Pebbles. I've
those
got
for
pebbles.
Emilia Clarke.
Pebbles, little fish rocks, like the kinds you put in the bottom of your fish bowl. Yep.
Did you hear my joke?
Yeah, sure, whatever.
Oh, Jorge said he saw your rocks.
Okay, I'm happy that he saw my rocks. I stole those rocks. I could have been arrested for stealing those rocks.
this channel does not condone stealing.
Rocks.
Well, should we wrap this up, Speed?
Yep, let's shoot it in the head. That'd be cool. I think we've done as much damage as we're going to do.
Yep.
Hi, Danny.
Oh yeah.
He's probably AFK.
Yeah, probably AFK. Anyway,
Zaft.
okay. So I think we will shoot it in the head tonight.
I think I'm just gonna start calling him AFK,
I was
Danny.
playing
Oh.
a game.
Yeah, you were AFK. Yeah.
All right, Danny, nice to meet you.
Let's play a
Hey,
game.
Danny.
Yeah, we're
Oh,
glad you
hello.
all stopped in. Okay, guys, I think we're going to kill it. So,
In Minecraft.
All right.
anybody have anything they'd like to say?
Don't
I mean,
learn.
I had a stream earlier tonight. That was fun.
I know you did, and I was there.
Yes,
Yes.
I may start streaming again regularly. I don't know.
Yeah, your streams
I
are
just
interesting. They're
I want to say the Bible is not a science book. That's all.
they're kind of like
Yeah,
a
that's
slow
good.
motion train wreck, which I really enjoy. I mean, they're an enjoyable slow motion train wreck. Like when it happens fast, people get hurt, shit, you know. But yours are just wonderful.
Wait, my streams?
I just gave you a compliment.
I know. I just I was like, what the
But you're
fuck?
trying to figure out exactly what the fuck the compliment was, aren't you?
Yes.
Okay, guys. Goodbye, cruel world. We're out of here.
Everybody.